Hello everyone, my name is Michael and this is a presentation on my final project for my digital forensics class. The application that I wrote for this project is called urIInspector, and for the rest of this presentation I'll be calling it Inspector for short. It is a web crawler and scraper, basically with a couple of forensic techniques built in. So Inspector is built on top of Scrappy and urIInspector. Scrappy is an open source web crawler and scraper framework meant for crawling and extracting structured data from websites for use in a wide range of applications. At its most basic, you simply create a spider that you tailor for specific websites you want to crawl and data you want to scrape, which the spider will then be fed to the Scrappy engine so that it could be run asynchronously. However, in my particular case, I tried to generalize my spider enough to run on any site, including those built entirely with JavaScript. Of course, this isn't foolproof with the web structured as it is, but it works in most situations. urIInspector, on the other hand, is not so much a framework but more of an API and web user interface to hook into Scrappy. I so much as don't use the API but have rewritten certain parts of urIInspector and added functionality to work for my needs in this project. So what does Inspector do? Inspector allows for extracting or scraping all kinds of textual and media files, such as the ones listed here, PDFs, video, audio, just to name a few. And then these files are saved into a Mongo database for further processing or retrieval. Inspector also has the ability to scrape multiple sites at once, including sites rendered through JavaScript, as I mentioned before. Also, some of the forensic tasks included is full text search of all the textual documents in the database, HTML archival, saving of web pages, and indirectly we could do file comparison using hashes, which I'll talk about during the demo. We could also view files and save files to disk on the server. So here are some of the main dependencies for Inspector. You have the twisted framework, which Scrappy uses, Tornado, which I use as a web server here, Scrappy of course, Beautiful Soup, which is an HTML parser, PyMongo, which I use as an API to the Mongo database, and of course the actual Mongo database application. There are other dependencies which I will have listed in the README file and report. So now let's take a look at Inspector. Okay, I'm gonna start the server. Okay, it's started. So let's go to the browser now and connect. Okay, so here is the main page. If we take a look at the top left, over here we'll see the CPU utilization occurring on the server and the RAM usage. This is actually good to keep track of, especially during multiple crawl jobs, because the CPU especially could spike up quite a bit. Next to that, we see a little widget here that displays whether the server is online, offline, or crawling. You could also click on it if it's offline to reconnect. Over to the right, we have a results link which shows all the files that are currently saved in the database. So if we click it right now, you won't see anything because this is we haven't performed any crawl jobs as of yet, and I'm working with a fresh database. Okay, so over here we have the crawl button and the input box where we put in our URL or website we want to search or scrape. And if we hover over the crawl button, we see that we need to make sure we have a scheme in front of the URL, which would be either HTTP or HTTPS. So below that, we have the deep scan option, which enables JavaScript parsing, as I mentioned before. So basically how this works is by using the Pi Virtual Display and Selenium modules. The Pi Virtual Display module is merely a wrapper for the X Virtual Frame Buffer, which is in itself a display server implementing the X11 protocol. Selenium is used to automate web browser interaction from Python. So by combining the two, we can create a WebDriver, as it's known in Selenium, that executes JavaScript within a headless or invisible browser. In my case, I use Firefox, so it's important to have Firefox installed on the server if you're going to use this option. So the execution of the JavaScript within the browser allows for additional HTML data to be captured or scraped. Excuse me. So below that we have the jobs panel. Here we will see all the crawling jobs currently running, or stopped, or stopping, or suspended, which we'll take a look at soon. And below that we have our forensics task. So the view file allows us to view any file in the database, and also to save that file to disk on the server. And we have also the full text search, which allows us to search using a string within any of the files in the database, textual files, obviously. So let's kick off a crawl job. So let's take a look at Scrappy.org first. So we're going to click on crawl, and there we go. So here are some of the categories or columns here. We have duration, that shows how long the job's been running, items, the amount of data that has been scraped, including PDFs, text, videos, so forth. The status, it's crawling right now, and if we look up here, you see it's crawling as well. That changed from online to crawling. And we have the seed URL that shows us that we issued a crawl job on http scrappy.org, and the ID number. And over here we have the stop and pause button, so we could actually stop a job or pause a job. If we click on the job number, we could actually see the items that has already been saved to the Mongo database for that particular job. Or if we go results, we can see all the jobs, scraped items. So actually, let's kick off another one. We could take a look at mysite.com. Click on the crawl button, and that comes under job number 2. It's pretty much the same information. So let's take a look at results and see what we have so far. And here's some files that have been scraped. It's from scrappy.org. PDFs, images, JPEG, PNG, and actually EPUB. So let's go back real quick. Since we have some items, let's stop these jobs. So it's stopping, and it should be shut down soon. Then we stop this one as well. Okay, so we have some items in the database. So let's first take a look at results again. And we have 6 pages worth of items, we could click settings here, and to show more items per page, let's go to 25. So we see Scrappy. Here's one mysite.com, and it looks like most of it's images, and you got a couple of PDFs and text. Yeah, here's some text here. So back in the settings, we could actually check here MD5 to show us the hashes for each of these files. So what we could do here is we could copy this hash and put it in the filter to filter out any files that will have the same hash, meaning the files are the same. So a forensics specialist could use a hash to discover if same file is being used in multiple sites. So this can be important if, for example, there's a particular file that should not be available, or like a top secret file that should not be seen anywhere else, as it could violate copyright infringement. So actually, let's remove this here. Let's take a look at one of these text files. I'm going to copy the index.txt and see if we could now view the file. So click view file, and we paste that file name in here. You only search by file name. Click the view button, and here's our file. And at the same time, a copy of this file was saved on the database. I'm sorry, it's saved on the server on disk. So let's actually copy this string here. This documentation contains, and then go back to the main page, click on full text search. Let's see if we can search this string. And there we go. We got 3 files of index.txt, and actually these 3 files have different hashes. They could be different versions, but they contain the string here this document contains. So here's the search string, here's the position that occurs in the document, and here's a sample showing what is around the document. So now let's go back to the main page, and now let's take a look at deep scanning. So first we're going to take a look at this web page before we check the deep scanning and see what jobs we can, or what items we can scrape rather. Okay, so that was quick. It only was able to get 1 item. But now, if we do the same crawl job and check deep scanning, let's see what we get. So that took a little while to start, and now we see we get quite a few more items, 6 items. So let's take a look at those items, and it seems like they're MP4s, video, audio items. So let's take a look at one of these audio files, which we should be able to view. So I click here, view. Okay. Let me pause that. So it plays the audio file. So we would not be able to get this audio file if we did not use deep scanning. So that's where that feature comes in handy. So now let's go back to the presentation. So for future work, I plan to add the ability to perform image comparison, where you can upload an image and compare it to other images in the database to see if there are any copies or similar images. This also ties in with copyright infringement or any forensic tags where you need to search for a particular set of images. Also, I would like to introduce a more robust PDF full text search capability, as the one used now is very process intensive. So thanks for listening, and I hope you have enjoyed the presentation.